now going to look at Chapter 1, Section 2 of this chapter of our textbook. We're going to be able to solve a formula for a specified variable. We're going to be able to solve applied problems using those formulas. We're going to solve percents. We're going to look at problems that involve a percent decrease or increase. And we're going to solve problems from the healthcare industry. First, a mathematical model is an equation or even an inequality that describes a real situation, just like a model airplane describes an actual airplane. Models for many problems are called formulas in math, so we don't typically use the word model at many levels in math or science. A formula is just an equation where variables are used to describe a relationship. So the area of a circle is pi r squared. That's called a formula because it relates the area to the radius of a circle. If I want to solve a formula, I'm just isolating that variable. So when it says solve the formula d equals RT for R, first I need to recognize that RT, when two things are written next to each other, it's multiplication. So I need to isolate R by getting rid of T. Since I'm taking R and multiplying it by T, the opposite would be dividing. So I'm going to divide both sides of my equation by T, which causes it to cancel out on the right-hand side, and I have now solved my formula for R. So to solve a formula for a variable, you're just isolating the variable. If you're looking for a set of steps, this is the closest we can get to a set of steps. It would be similar to solving a linear equation. You're going to clear any parentheses and fractions. You're going to isolate all terms that have a specified variable, and then you're going to isolate that variable itself. So if I have a little bit more complex of a formula, like P equals 2L plus 2W, and I want to solve this for L, the first thing is I need to get 2L by itself. Since I added 2W to 2L, I would subtract it from both sides to do the opposite, which simplifies to P minus 2W equals 2L. Now we have to recognize 2L is 2 times L, and the opposite would be dividing by L, or dividing by 2 to isolate L. When I divide both sides by 2, then I have this solved for L. So this is not very different, although your answer is not going to be a number, it's going to be a formula. Let's look at how this might be similar to solving an equation for x. I need to distribute 1/2 to both of my terms, which would be x over 2, 1/2 times 3 is 3/2. Next, I would want to multiply by the least common denominator. Since 2 and 2 have a least common denominator of 2, I'm going to multiply everybody by 2, which gives me 2y equals x plus 3. Now I want to isolate x, so I'm going to do the opposite of plus 3, which is subtracting 3. So now I know that x equals 2y minus 3. Notice x doesn't equal a number here. That's because I have two variables. I'm solving a formula for x, and my answer is going to be another equation. Now let's look at this one. Solve 2x plus 7y equals 7 for y. So my first step is I want to get 7y alone, and I will do that by doing the opposite of 2x, which would be subtracting 2x. It's subtracting because 2x is positive. So now I have 7y equals 7 minus 2x. I want to get that y alone, so 7y is 7 times y, so I will divide both sides by 7 to get y equals that simplified statement. If I want to solve applied problems using formulas, this is an example of a word problem. It takes James Harmon a third of an hour to travel 15 miles. What is his average rate? We will use the formula distance equals rate times time. And first, before we start plugging in any numbers, it's easier to solve for R, our rate. So to do that, the opposite of R times T would be dividing both sides by T, and I would get that my distance, or my rate, is distance divided by time. That would be the easiest way to solve this, unlike the way the textbook shows you. So I know that R equals the distance over time. My distance is going to be 15 miles, and then my time is 1/3 of an hour. So I can do 15 divided by 1/3, which is 45. The way the book shows it is not as much difficult. You would like to put your distance in as 15 and put your time in as 1/3. But here, you're going to have to divide both sides by 1/3. Sometimes it's a little more difficult. When we do this in a calculator, we want to type in 15 divided by, open parentheses, 1 divided by 3, close parentheses. Anytime we're multiplying or dividing by a fraction, it's very important that you put parentheses around the fraction itself so the calculator then recognizes this is a fraction, this is not a division or a complex fraction. If I want to solve percent problems, it's important to remember how we convert percents to decimals so that I know that percent to decimal means I'm moving the decimal place 2 places to the left in order to become a decimal. Or if I wanted to write it as a fraction, I have 1 and it's in the hundredths place, so it's 1 over 100. If I want to solve a percent problem, this is kind of a formula that we can use. The partial amount goes in the top numerator, the whole amount goes in the denominator, which gives me a decimal. Then I must convert my decimal to a percent. To convert a decimal to a percent, you move it 2 places to the right, or you can multiply by 100 if that makes more sense to you. So let's solve each problem here. A mixture of gasoline contains 20 ounces, of which 1 ounce is oil. What percent of the mixture is oil? Sometimes it can be hard to see what is the partial amount and what is the whole amount. The partial amount should always be less than the whole amount. So if I look at 1 and 20, the smaller value is 1. So 1 will go in the numerator and 20 will go in the denominator. You will divide this in a calculator or in your head and you get 0.05. But you're not done. We asked what percent of the mixture is oil. So I need to take that 0.05 and multiply it by 100 to get 5% as my final answer. If you enter 0.05 in the lab, it will not take the answer as correct. Here, an automobile salesman earns an 8% commission. They gave me the percent on every car he sells. How much does he earn on a car that sells for $12,000? So in this case, the 8% needs to go on the left-hand side, but it has to go as a decimal. So if I do 8 divided by 100, that gives me 0.08. Or if I move the decimal place 2 places to the left, that's going to be 0.08. Now, I know that 12,000 goes in the denominator because I can't make more than the price of the car as my commission. So my partial amount is going to be X. To solve this, I'm going to multiply both sides by 12,000 because the opposite of division is multiplication. And I get $960 for my commission. Here's another example. In 2012, Americans spent $53.3 billion on their pets. Use the graph to determine how much of this amount was spent on pet supplies or medicine. So if I look in here, pet supplies and medicine is 23.8%. So right away, I know I have to convert that to a decimal and that my statement is going to equal my percent. So I'm going to take 23.8 and divide it by 100, or move the decimal 2 places to the left, whichever you prefer. They're asking me what part of that 53.3 million did they spend on that item. So I need to take and multiply both sides by 53.3 because that's my full amount to get the X value of 12.7 billion. Because my units at the top were 53.3 billion, this is going to be 12.7 billion. When we're solving a percent of increase or decrease, it's very similar. I'm going to have my percent, which has to be a decimal, is equal to the amount of change over the original amount. So this is going to involve an extra step. A cost of living salary increase causes Keith's monthly salary to go from $1,300 to $1,352. What percent of increase was this? Well, first let's find the change. So the amount of change would be that 1352 minus 1300. If I subtract those two numbers, I will see that it's $52. You could also just immediately write in 52. The original amount was 1300. So when I do 52 divided by 1300, that's 0.04. But they asked me what percent, so I must convert that decimal to a percent of 4%. Here I have another example. The price of a concert ticket changed from $54 to $51.30. Here I had a decrease, right? It got cheaper. So I'm going to do my formula, and my change would be 54, the original price, minus 51.3, the new price, over $54. This is going to give me a change of $2.70 over my original price, which is going to be 0.05, but I need to give it as a percent, so I would have 5%. Notice it's not negative here, and that's because I indicated it's a 5% decrease, so it's implied that it was negative 5%. Let's look at problems from the healthcare industry. Here, I have a formula that's given to me, and I have some information that's also given to me when it says, what is the body surface area, which that's my S value, of a child who weighs 20 pounds, use K equals 9.082. So I'm just going to replace K with the value in the problem, and I'm going to use my calculator. Now, this is going to be very important to enter properly in a calculator. You want to first enter 4 times that 9.072 plus 7 into the calculator. Then you will enter the denominator and you will divide those two answers. Or you will enter with an open parentheses 4 times 9.072 plus 7, close parentheses, because that tells the calculator all of that information is in the numerator, divided by open parentheses 9.072 plus 90, close parentheses. Now, I do advocate for the use of the Web 2.0 calculator, because when you utilize the Web 2.0 calculator, you can see at the top what that fraction looks like, and you can make sure you have all the correct numbers in the numerator, all the correct numbers in the denominator. So you should get 0.44. Pause the video now, navigate over to the Web 2.0 calculator, and ensure that you get this answer before you try to move forward in this video or before you try to use anything in the lab. Here is another example of a formula. They are giving me this formula, and in the information, we're still using a 20-pound child if the usual adult dose is 500 milligrams. So what does 500 milligrams go to? That is my value for D. We're going to use the value from the previous problem for the surface area, and we are going to take and plug in D. So I'm going to get 0.44 divided by 1.7 times 500. Remember we said anytime we have a fraction, we enter it in parentheses. So it would be open parentheses 0.44 divided by 1.7 close parentheses times 500. This should give you 129.4. Pause this video and navigate to the Web 2.0 calculator, being sure that you get this exact answer before you move forward with this video or any of the practice problems in the lab. That's it for this video. Make sure you check out the other video on how to use the Web 2.0 calculator to enter complex fractions like the ones in the slideshow if you had any trouble with the calculation.